I'm Dr. P. Usharani, Professor, RMT Engineering College. In continuation of my previous video of EE 8702 Power System Operation and Control, Unit 1 MCQ, Solved Problems, Load Curve, question number 5 to 8, I'm going to explain. Already I have put a video for the load curve topic for 4 problems, question number 1 to 4. A power station has a maximum demand of 15 megawatt. The plant capacity is 20 megawatt. Find the reserve capacity of the plant. They are given 4 options. In the 4 options, correct answer is option A, 5 megawatt. How to find out 5 megawatt as the correct answer? The solution for that is reserve capacity formula is plant capacity minus maximum demand. So I'm just substituting the given data of plant capacity as 20 megawatt minus of maximum demand given value as 15 megawatt. So the result is 5 megawatt. So option A, 5 megawatt is the correct answer. Next question. A generating station has a maximum demand of 30 megawatt, load factor of 60% and a plant capacity factor of 50%. The reserve capacity of the plant is how much? They are given 4 options. In the 4 options, option C, 6 megawatt is the correct answer. How to prove option C as the correct value? I'm going to use 2 formulas. One is reserve capacity formula, which is plant capacity minus maximum demand. Second formula, plant capacity formula, which is equal to average load divided by plant capacity factor. Because in that problem, they are given data are plant capacity factor, load factor, maximum demand. You have to find out reserve capacity. The formula for reserve capacity is actually plant capacity minus maximum demand. Maximum demand is given in the question. Plant capacity is not given in the question. You have to find out plant capacity. So I am going for this formula, plant capacity. How to calculate my plant capacity as, if I know my average load, I can use this average load divided by plant capacity factor is given in the question as 0.5. So I don't know the average load also. So for that, what I'm doing, I'm going for the load factor formula, where load factor is equal to average load divided by maximum demand. You know the formula? So I'm just taken a load factor formula, average load divided by maximum demand. So from that, I'm going to find out my average load, which is you have to multiply load factor into maximum demand. So I'm just substituting load factor given data as 0.6 into 30 megawatt as the maximum demand. So the answer is 18 megawatt as my average load. Then if I know the average load, I know this value now. 18 megawatt as I have calculated, divided by plant capacity factor. Plant capacity factor is 0.5. So 18 megawatt divided by 0.5. If I put, I know my plant capacity. So 18 megawatt divided by 0.5. If I put my megawatt as plant capacity as 36 megawatt. Then I know my plant capacity. I'm going to use in the equation 1. Or I'm going to calculate reserve capacity, which is equal to plant capacity minus maximum demand. Plant capacity value is 36 megawatt calculated minus maximum demand given in the question as 30 megawatt. So the answer is 6 megawatt. So the option C is the correct one. Next one, a thermal generating station has an installed capacity of 15 megawatt and supplies a daily load of 10 megawatt for 12 hours and 5 megawatt for remaining 12 hours. The plant capacity factor is how much? They have given 4 options. In the 4 options, option D is the correct one. You have to work out and prove. So for that, kindly read the question. They have given for a day 24 hours. They have given the load details for a particular time 12 hours 10 megawatt, and remaining 12 hours 5 megawatt. Okay, so I'm going to use the formula plant capacity factor, which is equal to average demand divided by rated capacity. The rated capacity they have given us 15 megawatt. So 15 megawatt per day means 15 megawatt into 24. And average demand for 24 hours, they are given two different loads for particular time duration. So now I'm going to multiply with my load with the time duration. So I'll be getting the answer in megawatt hour. This also megawatt hour. I am adding these two, that is 24 hours with the different loads. Okay, so my average demand is in megawatt hour divided by, again, rated capacity as with, you have to cancel out the megawatt hour. So megawatt, 15 megawatt into hour. You are multiplying per day 24 hours. So my answer is 0.5. So the option D is the correct one, 0.5. For the same model, with the power factor they have given means, how can you calculate? So an industrial consumer has a load pattern of 1000 kilowatt at 0.8 power factor lagging for 10 hours and 1500 kilowatt unity power factor for 14 hours. What is the load factor value? They are given four options. Option B is the correct one, 0.8. How? You have to use the formula load factor is equal to average demand divided by maximum demand. So here they are given with the power factor. So you are multiplying with the kilowatt and power factor, then the time duration. Okay, each load for 24 hours per day, you have to multiply and add. That is your average demand. So first load they have given us 1000 kilowatt at 0.8 power factor, then 10 hours. So you are multiplying this and adding with that with another load of 1500 kilowatt at unity power factor 1. Okay, then for the duration of 14 hours. So you are multiplying this and adding with the previous one. Then that is your total average demand divided by maximum demand. Maximum demand in the two loads 1500 for 24 hours. So you are using dividing your average demand divided by maximum demand. Your answer is 0.8. So option B is the correct answer. Thank you. Now I am going to brief about the next topic, parallel operation of alternators, in my next video. Kindly watch my next video also. Thank you.